Hello, everybody, and welcome to day 2 of our Cloud Hero event, Data and Machine Learning with BigQuery. Happy to see so many familiar names from yesterday's event and new names too. If you weren't able to participate in our event yesterday or our prep events, no worries. We're glad to see you today. We're going to be going over some of the same content just to catch you up and then taking what we learned yesterday and going further with it. So with that said, let's go ahead and introduce today's presenters. We have Andrew and Aditya on the screen. Hey guys, how's it going?
It's going well. How about you?
Hey, doing great. Really excited to jump into some BigQuery and machine learning today. Yeah, so I'm going to go ahead. I'll introduce myself. My name is Bobby Bergenon. I'm the current DSC lead at the University of Wisconsin-Madison. Little plug. I'm really excited to be here today with you all. I'm an undergraduate student studying computer science, and I will be the moderator for today's event. With me, though, we have Andrew and Aditya. Aditya, do you want to go ahead and introduce yourself?
Absolutely. Thank you so much, Bobby. So I'm Aditya. I am the DSC lead here at Georgia Southern, another quick plug. And I am a senior in my undergraduate in data science, and add me on LinkedIn.
And hello, everyone. My name is Andrew Dimmer. I'm the DSC lead at Oakland University in Michigan, where I'm double majoring in computer science and mathematics. And I'll be going through the fourth and final lab of this Cloud Hero event, predicting visitor purchasing using BigQuery machine learning.
Awesome. Well, thank you guys for the introductions. Really excited to hear more from you guys during the lab walkthroughs. But in the meantime, let's drop Andrew and Aditya off the screen and go ahead and talk about a little bit about the help that we're going to have during today's event. Oh, first of all, go ahead, add us on LinkedIn. It's our names. So we're happy to connect with everybody out there. Please go ahead, add us. We're happy to answer any questions you guys have about DSC, or if you just want to chat, get to know more about the DSC community, let us know. Now, let's go ahead and introduce our Discord mentors. We've got 5 great mentors today: Adi, Evelyn, Sahel, Aaron, and Manoj. So be sure to reach out on Discord. Scan that QR code that you see on the right-hand side of the screen and join our Discord channel. It's bit.ly/DISCTOTV. So links right up there on the screen for you. There's going to be 2 voice channels, the Q&A lobbies 1 and 2 for you to join with your real-time questions where you can interact with people face-to-face to help answer your technical issues. There's also going to be another channel, the Cloud Hero channel. So you can type your answers in that one or join the Q&A lobbies to talk with our mentors face-to-face and share your screen. One quick thing to keep in mind is that when joining our Discord server, in order to be able to see all the channels on the screen, you're going to have to go to the rules channel first. So click on rules channel, just like it's showing in the GIF, and then go all the way to the bottom and click on the green check mark to be able to see the rest of the channels. Again, go to rules channel, scroll all the way down, and then click on the green check mark. Another thing I'd like to mention is that this is being put on by developer student clubs. So be sure to join your DSC community. Go to the link dsc.community.dev and find your local chapter. In the header, there's an option for chapter. Click on it, and you can type in your university. So for example, if you're part of UW-Madison, just type in Madison. It'll be the first one that pops up, and then click join. That will get you on the email list for all the clubs and show you how to join all the different events. Now, if your local community doesn't have a DSC chapter, feel free to join any other DSC chapter. They're all welcome to join any chapter you'd like. They'd love to have you, especially in a virtual environment. We're not meeting in person, so everybody's welcome. DSC offers some great content for you. Besides just learning the skills that we're going to be going through today, we put together other study jams and quick lab sessions, as well as social events and ways to network with other people around you. On LinkedIn, it said they did a study that 85% of people get jobs through referrals. So it's a great way to network with your community, learn more about the tech community, and have a great time while you're doing it.
I cannot agree enough. Being able to go network, especially when everyone's virtual on campus, is key. Bobby, really quickly, if you want to go double check the full screen, we're still getting some bars on the stream there.
Oh, I've got you. Just a second. There we go.
There we go.
Thanks for the tip. Yeah. Sometimes I get a little nervous when presenting, and a lot of people say to, imagine people in their underwear. I don't like that. That's a little weird. So I just try to imagine your smiling faces on the other side of the screen. So keep those smiles up. I'll see them through the screen. Just kidding, I won't, but I really appreciate it. And make sure to be active in our YouTube channel, in the comments. Put all your questions there, all your ideas, what you want to see from us. Be active because we're here to cater to you. We want to know what you need help with while you're following along and what you want to see from us. So join in our Discord channel, in the Q&A lobbies, in the Cloud Hero channel, and in the YouTube chat. Our agenda for today, we just did the welcome, then we're going to go over a little bit about what Google Cloud is, then a Google Cloud recap, a Cloud Hero recap from yesterday, what we started on during our Cloud Hero series, and then how to play the game, how to set up, making sure that you have the right resources to be able to complete the labs and get your badges and become a Cloud Hero. After that, we're going to have the walkthroughs from Aditya and Andrew for labs 3 and 4, and then we're going to wrap it all up with a Q&A session and a couple wrap-up videos for you. Yesterday, we talked about the cloud. The cloud, in the way that we're using it, it's not the clouds in the sky, as cool as that would be, if that's where the internet was. Cloud computing can be a confusing term, but at its most basic level, it means that we're getting things done using someone else's computers over the internet. So all those data warehouses that Google has that we saw pictures of yesterday, that's where we're getting data from. It's being transferred over the internet, and now we have access to them in the way of the Google Cloud Platform, which is what we're going to be using today. Google's Cloud Platform allows us to use Google's computing infrastructure to help us run our applications online. Now, what is Google Cloud? It's a suite of secure storage, innovative machine learning, powerful computing, and integrated data analytics products and services. So there's a lot that goes into this, a lot of different services and applications that we're going to be able to use online. And we're going to be going over a few of those in today's lab, such as BigQuery. Cloud technology requires new skills, and that's why we're here today. So whether or not you just want to get a badge saying that you completed this and put it on your LinkedIn profile, or if you want to get a certificate, or if you're working to become a Google Developer Expert, we're here for you to help you in a more basic level to help build your credentials and your skills as we go. But why is this so important? If it's just to, develop some skills, or, if you're just doing this to get the badge, maybe that's not enough. What does this mean to you? The reason that we're doing this is to future-proof your career. So with all these skills that you're going to develop during these sessions, it's going to help you build your own portfolio, your own skills to be successful in your future careers and have a fun time while you're doing it. The growing adoption of cloud computing is a driving demand for cloud talent. So as everything is becoming virtual, especially in coronavirus, there's a lot more need for people to work virtually and be able to have the skills to be successful in their careers. What does this look like? Well, we see that Cloud Hero skills continue to be in high demand. The increase in Cloud Hero adoption has resulted in a corresponding increase in the need for workers skilled in cloud technologies. Employer demand for cloud computing roles, including infrastructure, security, architecture, and engineering, rose almost 33% in the last 3 years, according to Indeed. Finding qualified cloud talent is also one of the top challenges for IT leaders. So by completing these labs and taking these steps to further your skills, you're going to be putting yourself at a competitive advantage against those who you're competing against for jobs in the future. This is seen in so many places where you're going to need these skills. Whether or not you're focusing in a technical area or a non-technical area, these skills are going to be applicable to you. For example, computational development, user experience, and support and operation skills are needed for all of these different areas. You can see even as a sales rep, whether you're in the IT field or not, you can use these platforms to leverage your control over the market. Or if you're a network admin, where it's a highly technical area, you're going to need all of these skills. So take a look at this. If any of these future positions sound exciting to you, then you're in the right place. These are the skills that you're going to need to learn to be successful in your career. For a spectrum of skills, I've personally found this slide the most interesting. Looking at what types of skills from a scale of low to high will you need for your different area. It's a really good way to kind of visualize where you should be focusing your time. So between collaboration, customer and user integration, and technical knowledge, you can see it ranges anywhere from sales rep and technical knowledge to software engineer. Now, we're going to be focusing more on the technical skills today. So take a look at this bottom section. Do you want to be a software engineer? You're going to need a lot of this knowledge. Even as a sales rep, like I said before, you can use machine learning to maybe get a better idea of your market segment and see, how potential clients are reacting with the information that you send out and how to maximize your influence. Now, that's a little bit about machine learning and what it can do for you, especially with Google's cloud platform. But what is Cloud Hero, and what are we going to be doing today? Cloud Hero is a virtual hands-on training event using the game functionality on Qwiklabs to help technical practitioners gain skills through interactive learning in a fun and a competitive environment. Cloud Hero brings developers together to compete against one another in gamified labs using their Google Cloud skills. It's one of the many interactive products from the Higher Education Learning Center from Google Cloud. And overall, it's one of the many steps towards the path of gaining some perks and certifications. So by completing these labs, you're going to get some badges and you're going to develop your skills along the way. So from yesterday's event, you saw we went through the BigQuery, Quick Start Command Line Lab, and then getting started with BQML, which you might have seen me lead in yesterday's event. But today we're going to be focusing on weather data in BigQuery and predicting visitor purchases with a classification model in BQML. If all of this sounds really confusing to you, don't worry. We're going to be breaking it down step by step so you guys have the tools to complete it along the way. Now, there's some benefits for being a student as a part of DSC and participating in this event. First of all, you'll have access to free credits, 200 Qwiklab credits, which will allow you to learn the skills needed beyond machine learning and data. All of the different cloud platform, or all of the different applications and technologies across the cloud platform will be available to you to use and experiment with using these different Qwiklabs. Discounted credentials too. So if you want to take the next step and take your badges and gain a certification, you'll have discounted credentials for that in terms of G Suite and Data Analyst Track 2. There's also on-demand training. There's 13 courses on Coursera that you have access to, 6 career learning paths in app dev, AI, big data, and 3 introductory courses on Google Cloud as well. Now, this is a really important slide, I think, for y'all. So be sure to go to that link that you see on the screen, g.co/learncloud/programs. This is how you're going to get those 200 Qwiklab credits. And these credits are valued at $1 a piece. So this is a $200 value that you guys are getting for free as students. So I can't stress this enough. Please go to that link. You'll be able to learn in your own time these different technologies that other people will have to pay for, but you, being a DSC member, will get for free. Cloud Hero data and ML recap. So this is a little bit of what we went over yesterday. Let's continue. We learned yesterday that machine learning is learning from rules plus experiences. Instead of taking the traditional approach of the diagram where rules and data are used to create answers in classical programming, what we do differently with machine learning is you actually start with the data and answers, and this is your training material. So you use an algorithm like TensorFlow, for example, and use it to integrate rules that you can use to make predictions for future pieces of test data. Basically, you can use past data to learn patterns that will help you evaluate new data, maybe even make predictions for the future. So what's really cool about this platform is that it democratizes AI by making it fast and useful for all developers and users. All this data that we have access to is bringing the machine learning to the data. Instead of taking the data and bringing it to the machine learning aspect or platform, which would take a lot of time, a lot of energy, a lot of computational power, we're doing it a little bit differently, where we're taking the machine learning, bringing it to the data, and making it accessible over the internet, over the cloud. So this makes it a lot faster for you guys to create these models, and you'll develop your own machine learning models and predictions in less than an hour. Here's an example of how machine learning is being used today to save the world of bees. So let's take a look at this video.
For such tiny creatures, bees have one of the biggest jobs in the world.
Hi, I'm Katharina.
And I'm Frederik.
And we're using machine learning to better understand how nature works.
And we're doing that by observing bees.
Bees have a symbiotic relationship with nature. Plants depend on the pollination of bees, including the fruits and vegetables we eat every day.
Bees and other insects are dying around the world, and we do not know why.
We don't want a lack of knowledge to be the reason bees continue to disappear.
I thought we have to do something about it. So we built a hive monitor that uses a camera to track the bees as they come and go. Bees always return to their queen. If we observe 500 leaving the hive and only 200 returning, we can assume that there's a problem in the local ecosystem. We trained a model using TensorFlow, Google's open source machine learning framework that examines the video from each hive.
But what do we do with all this data we collect?
We share it with experts so they can make more informed decisions on things like when to mow lawns and where to plant trees and flowers, so bees can continue to power our ecosystem. This tech is only the first step. Us humans will have to take it from there.
Wow. So I really like this video because it really shows the social impact you can have with machine learning and data technology that we have over the Google Cloud Platform. This is something that'll be really useful as a DSC member if you decide to participate in Google's Solution Challenge. So using this content will help you have a social impact in your surrounding community and making that scalable to the world, just like they did in this video. So let's get started and learn how to play the game, how to be involved in this Cloud Hero event. There are some tips and tricks we're going to have to use. And so I'm going to go ahead and explain those to you piece by piece to make sure that everybody has access and is able to complete the labs. If you don't, and if you're having issues, be sure join in on our Discord channel. The Q&A lobby is where you'll probably get your questions answered the quickest. So be sure to be able to share your screen, and then you'll be able to walk through step-by-step your issues with our mentors. First of all, key step is opening an incognito window. So on Windows, this is Control-Shift-N, and on Mac, Command-Shift-N will open up a incognito window for you. The reason why we do this, I mean, you can do it without an incognito window, but the reason why we do this is to ensure that you don't get charged for participating in today's labs. Sometimes there's some technical issues where if someone uses their own ID to log in, then it'll ask you for credit card information. If you ever see a prompt that tells you to put in a credit card, do not do it. We're here with a free access code and a free link so that you guys can do it yourselves without having to pay. So that's why we open up an incognito tab first. And then join or sign into Qwiklabs. So just go to Qwiklabs, which is the google.qwiklabs.com, and then you can either join or sign in if you already have an account. And here is where you can use your personal account to log in. If you participated in our event yesterday and you already started these labs, make sure you're using the same credentials to log in to make sure that your progress from yesterday is kept. Next, and this is optional, but we recommend taking a look at it, is going to your profile icon in the top right. Then click on the blue button that says My Account. In the left menu panel, then select Profile Info and scroll down to the language field. If English isn't your first language, or if you prefer to work in another language, go ahead and change it accordingly. And then finish by clicking the Update User button. If you decide to stay in the profile info page, please do this and change your player name in the text field for the Quick Labs games. You can enter your preferred player name. I'm sure this won't be an issue, but I just want to give you a heads up. If there are inappropriate names, they will get banned from the game. So make sure it's appropriate, and this will be the name that'll pop up on the leaderboard. And then click Update User button at the bottom to confirm your changes. Now, this is the important information that you're going to need to join the Cloud Hero event for free. So be sure to use the game link. It's in the footer on the slides. Also, the game link is provided in the blue text above. It's bit.ly/dsc-na-cloud. That'll bring you to our Cloud Hero game. Also, then it'll ask for a code. The code that you're going to need to use is the one listed below, the 2F-EDUCR-DSC. This will get you free access to the game so you don't have to pay. Also, if you'd rather scan a QR code, go ahead, open Google Lens, and scan it right away. I'll stay on the screen just for a couple more moments, just so you all have a chance to open it up in your browsers. Remember, make sure it's an incognito window. Type in the link above or scan a QR code, and then when it prompts you for the game code, that's the one listed in yellow or white at the bottom in the footer. Once you have it opened up and you enter in the code, this is the kind of screen you should see. It says Cloud Hero University Data in ML or something like that, and then there should be 4 labs listed below. If you have this screen, you're in the right spot. If you don't, be sure to hit up our Discord channel, ask your questions there. We have 5 mentors, more than happy to help you. That's what they're there to do. So don't be shy. Even if you are, and you don't want to talk over audio, you can put your questions in the Cloud Hero channel as well. Like I said, today's game and the game that we started yesterday, it'll have 4 labs. We're going to be going through labs 3 and 4 today. Aditya will be doing lab 3, Andrew doing lab 4, and we'll have them talk about it. But for each lab, remember to use the new username, password, and project ID that Quick Labs assigns you. So when you open up where it says Start Lab, once you click Start Lab, then it'll prompt. Those are the codes that you're going to have to enter when opening up the Google Cloud Console. So it'll say use another account. You want to make sure to click that button and not use your personal account, and copy and paste the username and password provided to you. This makes sure that you get access for free, and it opens up Google Cloud Platform in an instance. So this is username and password you're only going to be able to use once for the duration of the lab, 45 minutes for lab 3, hour and 15 minutes for lab 4. So don't reuse these IDs. They won't work for you again. It's just a one-time passcode. So choose one of the labs. In this case, we're going to be starting in lab 3. And then you don't click Start Lab just yet, because we'll have Aditya walking through it with you. But that's what it should look like in the GIF on the screen, where you can start lab, and then you'll see the timer counting down. Now, for our first lab, you will have 45 minutes to complete it. Don't worry, there is some extra padding for you to follow through with the walkthrough as we're talking about it. But for the sake of the Cloud Hero event, ranking is based off of time. But that said, it is important that you're not just copy and pasting the codes. Make sure that you're understanding the content. Otherwise, you're not really taking anything away from this. Another key step, and this is absolutely imperative if you want to be included on the leaderboard and get your badge, is to make sure that you click End Lab when you're finished with it. After you go through all the checks and you see all the information that you created and provided is correct, you'll have to click End Lab to be able to make sure that your score is uploaded in the leaderboard and that you have access to your skill badge. So our Lab 3 will be focusing on weather and big data query, like I said, and that'll be hosted by Aditya. And a pro tip, if you're having issues opening up the Google Cloud Platform, what you're going to have to do is make sure that your project ID matches the project ID listed in the top of the header there, right next to where it says Cloud Hero. It should say your Cloud Hero token, that'll be your project ID, and that should match what's provided in your credentials right below the username and password that's provided to you by Qwiklabs. If that doesn't match, try relogging in again with the username and password that Qwiklabs gives you. Timing and score, I touched on this briefly earlier, but points are earned by completing the steps in the lab, and bonus points are earned for speed. That said, remember, take your time and understand the content that you're learning, because that's what's going to help you in the future. And be sure by the end of each lab to click the end option to get maximum points. Now, let's bring Aditya back to the stage and get started with everything that we've learned about Qwiklabs now and take that into Lab 3. Hey, Aditya, how's it going? Oh, I think you might be on mute. There we go. Hey, how are you doing?
Thank you, Bobby. I'm doing well. Thanks so much for that explanation. I mean, every time we go through new benefit for DSC students, it's always so awesome.
Yeah, you know, we have a lot of great technology out there for everybody to use, and I'm just excited that it's free. You know, before joining DSC, I had no idea that this technology was out there, and now that it's free, it's even better. But so what are you going to be going through in Lab 3 today?
Yeah, so today in Lab 3, we're going to be doing weather data and complaints in New York. So what we're going to be doing is seeing if there's a correlation between the weather and the temperature and the wind and complaints about appliances in your house breaking down. As we go along, make sure we ask questions in the Discord and YouTube chat, especially the Discord that Bobby linked earlier. And Bobby will be hopping in and out as we continue to make sure your questions are answered. So I'll see you later,
Awesome.
Bobby.
See you later.
So as we get started, when you click on that link in the chat, as well as the link Bobby said earlier, and make sure your code's entered, make sure you're in an incognito window. And you're using the account that you used yesterday. If you don't worry about it, you can use whatever personal account you'd like. Just make sure you're in an incognito window. The link looks something like this. We'll scroll down, and you see here we have some scores for people that participated yesterday. And we'll scroll down to Lab 3. We'll be working on weather data in BigQuery. Oh, we want to, before we get started, we want to make sure we're not starting the lab yet. We're going to go through some data first and go talk a little about it a little bit, and then we can start the lab afterwards. What we'll talk about is what is BigQuery. So on Google's website, we have a definition where BigQuery is an enterprise data warehouse that solves this problem by enabling super fast SQL queries by using the superpower of Google's infrastructure. Let's break that down a little bit. What that means is that we have access to a tool that we can use in the Google Cloud Console to write SQL commands and process our data really fast, really easy. As we scroll down, we actually get to see we have some amazing features in BigQuery, and we're using a really cool data set here. So some of the most amazing features of BigQuery are the fact that it's serverless. There's no need to download the data to your machine, and the data is always going to be in the cloud. This is beneficial for a whole of reasons, but a primary reason could be the ease of use. As we see our next example, what BigQuery allows you to do is ad hoc SQL queries on your data set. What that means is whenever you need to, you can run any data set, any query you need. It also scales because it's on the cloud. So we're able to do this on large data sets instantly. And because it's online, we're able to share it with whoever needs it whenever they need it. Before we get to a quick graph showing plotting the number of complaints by the temperature in things in New York, let's make a quick prediction here. Right now, where I live, it's about 71 degrees Fahrenheit or 21 degrees Celsius for those outside of the US. And it's a nice, pleasant day. But when it gets hotter and colder, do you think that we would see more complaints or less complaints if things like, for example, if it gets colder, if the heater's not working? take a second to make a prediction. Post in the Discord or the YouTube chat. Yeah, so sorry about that. It looks like I disconnected for a minute. What I was saying was, make a prediction. Let's see if let's make a prediction. Post it in Discord or in the YouTube chat to see if as it gets colder or hotter, if your heater breaks down, for example, if it gets colder, do you get more complaints or less complaints?
"12 seconds later."
I see some responses, and absolutely, you definitely get some more complaints, and that's something we actually see here on this graph. Here we have a graph of the a problem with the heater in daily temperature in New York, and as you can see, as it gets colder, clearly we see a lot more complaints. You don't really need the heater when it's 99 degrees outside. This is what we're going to be working on today's lab. We're going to be doing some basic data analytics to make sure we are. So some quick setup. Definitely, like we were talking about earlier, make sure you're using Google Chrome. Google Chrome is probably the best browser for this. We want to make sure we're in an incognito tab to make sure we're not charging our own personal account. So with that being said, I'd like to get started. So to get started over here, we're going to click on Start Lab, this little green button over here. And we're going to make sure that we're not a robot. This is the hardest part of the lab. We're going to select a bunch of tractors. So this one, and this one. Awesome, y'all. So let's get started. So what we're going to do is we're going to hit Open Google Cloud Console right here. It'll ask us to sign in. Luckily, we're provided with a login and password. So we're going to take our username. We're going to copy it by clicking this button right here. We're going to paste it. Control V. And now we need our password. We're going to accept our terms of service here. And we don't really need to put in our own phone number or email address because we're only going to be using this account for 45 minutes. As we continue, please make sure that you are posting your questions in YouTube and Discord chat. And yeah, make sure you're posting any comments you have, questions, anything like that in the YouTube chat. So very important. So this is the Google Cloud Console. If you've seen this before, great. If not, don't worry about it. We're going to go through this nice and slow. We have to service. I am in the US, so I can leave it like that. If you're not in the US, just select whatever country you're in, agree to your terms of service, and continue. Awesome. So let's go down a little bit. The first thing you want to do is you want to open BigQuery. Now, you'd expect BigQuery to be near the top since it's alphabetically organized in some way, but it's not. So we're going to actually have to scroll down quite a bit to get down to Big Data. And then we'll scroll down to BigQuery right here. Click on it, open up BigQuery. We don't need that today. And here is our BigQuery menu console. So what we're going to do today is we're going to be using a public data set from the NOAA, or National Ocean and Atmospheric Administration, I believe. To do that, we're going to be adding a public data set into our BigQuery, console. So the first thing we're going to do is we're going to go to Resources, Add Data, and Explore Public Data Sets. While we're waiting for this to load, Remember, please ask any questions that you have in the chats. I will best to keep on them, and I'm sure Bobby will hop in at any time to them. So here's some amazing data sets that you have access to. Before we go and find the data set we're looking for, I definitely recommend just taking a second to look at what's here. There's a lot of really cool data sets that you can work with and provide all sorts of analytics. You know, right now, there's a COVID-19 data set. Obviously a very important problem. And there's definitely, and here's another cool one that I actually really liked, a cloud to ground lightning strike data set. Not sure what that is, but I think it sounds cool, so I definitely want to work with it soon. So the data set we're going to be looking for is a data set called NOAA GSOD. To find it, we're just going to type in NOAA, oh, that's caps lock, _GSOD. And we'll see here, this is a global surface summary of day weather data. Click on it. And we're going to click on View Dataset right here. So what's the weather like in y'all's area? Go ahead and post it in the YouTube chat while we're waiting for this to load. A little bit overcast over here. Pretty decent temperature though. No wind. All right, awesome. So here we have our data set loaded in. As we can see, we can click over here on our resources tab, and we'll see there's a BigQuery public data tab here. So the first thing we're going to do is we're going to open this up, and I'm going to go ahead and make sure that we are staying up to date here on our BigQuery page. And we're going to find our GSOD 2014 table. So we're going to type in GSOD, and we see here we have our NOAA _GSOD table. And we're going to find the 2014. So it's 2014. Awesome. That was 6 years ago. That's crazy. So we want to make sure we can preview our data so we can see what our data looks like. So let's do that. You see here we have a station, we have a year, we have a month, a day, some temperatures, some wind, and some other values as well as we continue. Some rain, snow, tornadoes if they were happening, all sorts of cool stuff. So what we're going to be doing is we're going to be using some SQL to do some quick data analytics on on the data set. So before we copy and paste and run this SQL, I'd like to just go over it real quick. So actually, let me copy and paste it over before we do that. So I can go over from here. See here, there are certain words that are in capital letters. Those words are usually commands. So as we go through, I'm going to be highlighting those words and talking about them a little bit. The first one we want to talk about is select. What select does is, as the name implies, it selects data to select some data that you want to use, usually in the terms of rows and columns. So here we can see we select our station, STN. We create kind of a timestamp with all the date values that we're going to be using. We get some average values, or we say that if the values are out of range, because as you can see here, we have some values that are a little bit ridiculous. For example, here we have our wind speed as 999.9 miles an hour. That's a little bit concerning. So we want to make sure that those outliers are handled. So we do a little bit of math here, just taking the average of the rest of the data set to understand what's happening here. We do that for our temperature, wind speed, and precipitation. Then we talk about our from command. Our from command just selects which table we're selecting it from. As you can see here, we're selecting it from this table here, the BigQuery-public data-data .noaa_gsod, so that's over here, and we're selecting from gsod 20. The next command that's very important is our where command. So this allows us to specify what data we want. So what we're going to do here is we want to compare the year, and we want years that are larger than 2010, meaning sooner in the last decade. So we're going to make sure it's an integer. We want to make sure that it's January, February, March, April, May, June. So we want to make sure that it's in the month of June, and it's June 12th. And we're going to make sure that these are in New York, so LaGuardia and JFK airports. The last two commands are a group by and order by. What our group by does, it allows us to group our data types or data entries. So if we have, for example, things that are coming from the same station, they'll be closer together. And then we want to order it by our timestamp and our station. So we make sure that we are ordering our data so that we see things in, for example, we see 2014, then 2015, rather than 2015 and then 2014. So we're going to run this query, and I highly recommend when you have some free time messing around with this, getting familiar with how this works, deleting some parts, adding in parts as you see fit. We'll run this query here. And as you can see on a data set processing 3 gigabytes, we did it in less than 2 seconds. This is the power of the Google Cloud and BigQuery. So we can see what we've actually done some processing on, and we can see our results here. Here we have LaGuardia on June 12th in 2020, and the temperature is 78 degrees with a wind speed of 6.8 and precipitation value of 5%. So that's pretty cool. Now, it's going to ask us to check our progress as we go along. This is very important. This allows us to make sure that we're completing the lab and that your progress is measured. So we're going to go ahead and do that. Oop, I have missed something. Let me hide my editor so we can make sure we see everything. Let me try this again. Sometimes it's a little bit slow. Let's go back to our query. Let's run it again. Let's check that. Oh, looks like I made a mistake. Maybe I did something with the project ID. Let's see what I did wrong. Hey, Andrew, do you mind hopping on for a second to see if see what I did wrong here? I can't seem to find it for a second. I'm running it under the wrong project.
Hey, really quickly, and this is a good heads up for everyone, actually. Notice how your account is currently set to your personal account. What ended up happening was your account must have changed when we went to the public data sets. Sometimes that happens because you're opening stuff up in new tabs. It happens all the time, but that is one of the reasons we do recommend doing something in an incognito window. It minimizes the chance of happening. Now, Aditi, I think you were probably logged in an incognito window for something else anyway, which is why we ran into that. But just as a reminder to everyone, and this is key anytime you're opening up a new tab, number one, you should double check that you're on the right project using the Quick Labs credentials. And again, you can verify that on the Quick Labs page there. Number two, double check this project ID in that upper corner where it currently says select a project. Once you do that, you can drop down, grab the Quick Labs project from the list. Sometimes you'll need to click all depending on exactly what happens. And that'll make sure you're all set. Now, it's really cool for BigQuery that even if you do accidentally use your personal project, though, you're not going to be charged for it. Because with a public data set, and this is true for everyone, even before you get the education credits, you get 5 gigabytes of queries each month to go play around with public data sets. So even after you're out of Quick Labs, even after you've done all the training, even after your 30 days on Quick Labs expires from, coming to this event, you can still play around with BigQuery on your own, totally for free, just with that 5 gigabytes a month quota to go try it out with different public data sets.
Thanks so much for the save, Andrew. Yeah,
Not a
so
problem.
like he was saying, I was apparently in the wrong account. I was using, so make sure you are in an incognito window. I was, but you're also logged into the right account. And you can select your project up here from the top left-hand corner. Make sure we're using our Quick Labs project. You can double check this by seeing your project ID right here. So we're going to go through our steps again. We're going to go through them real quick to make sure that we're on point. Add our data set. It's a public data set. We're looking for our GSOD data set. There's a lot of NOAA data sets, so it doesn't help too much by running that little search. View our data set here. I'm actually going to go ahead and close these tabs. And we're going to find that GSOD 2014 data set again. There it is. And just going to copy and paste that query in here. And it's the same query as earlier, not changing a thing. Going to run it. As you can see, we have the same result. And now let's check it to make sure that we are in the still getting, oh, it transitioned again. That's not right. Let me actually go ahead and sign out. Sorry about that, y'all. All right, so now there's no way you can log into my account. One more time, really quickly. NOAA underscore GSOD. There it is. To view that data set, gonna double check that it's the right account. It is. Don't see my beautiful face right up here. Gonna find the 2014 GSOD data set. And that is the password, not the query. Let's go back, make sure we copy the query over. And now it should be working. It's not. Let's give it a second. Try it again. There we go. Perfect. All right. So now it works fine. When you have that green check mark, you're ready to move on. So what we're going to do now is we're going to select our new project, and we're going to select our service requests in New York. So let's go ahead and do that. So we're looking for New York through on service requests. See if we can find that here. New York, an underscore. It is And here's our 3-in-1 service request right here. This is what it looks like. Again, we can preview our data to kind of see what's happening. And you can see a unique key, an agency, and a complaint type. So we're going to compose another query. Let's go over this real quick. Compose a new query here by clicking this Compose a New Query button. We want to make sure we're showing our editor. We hit it earlier. And again, we're selecting. Now this command right here, the extract command, all it does is it removes certain parts from the date. So for example, you'll see here we have 2011 June 5th. We just want the year. So we're going to extract our year from our date. We're going to get our complaint type, and we're also going to count the number of complaints that we have. This just tells us where we're getting it from. And again, we're just grouping by and ordering the data set based on its year, complaint type, and the number of complaints. So if we run this query, we can see our results. And as you can see, there was in 2017, there was about 230,000 noise complaints, which is quite a lot. So we're going to use this data and the data we got before and some data we're going to extract next to get that graph that we were talking about earlier. We're not actually going to get to see the graph, I don't think, but we just want to see a correlation value in there. So now what we're going to do is we're going to create our own data set. So in the left pane of our BigQuery console, we are going to create our own data set. So if you look here, you'll see that we can find, we want to scroll to the top. Where is my project? There it is, right? And we can click on our project, make sure we delete our search query. And we're going to click on Create Dataset right over here. Now we want to make sure we name our dataset right. So we're going to name it Demos, B-E-M-O-S, completely lowercase. That's all you need to do. And remember, as we keep going, please ask questions in the chat in the Discord. And if there's anything that's going wrong, I'm sure Bobby will pop in and let me know. So yeah, please keep asking those questions. We have some wonderful mentors. So make sure we're creating our ID like this. I'll actually pause here for a moment. Maybe take a quick water break while I wait for y'all to catch up. I see some comments in the chat that I missed earlier. It's cold in SoCal. Amazing. Usually it's very hot in Southern California. So that's cool. Let's go ahead and create this data set. Awesome. So now you can see here, we actually have our demos data set right here. I'm going to go ahead and click on it. And let's check our progress to make sure that we're on track. All right, so we got another query here coming along. This one is a bit complicated or a bit long or blocky looking. So we're going to compose another query. We're going to paste it in. And let's go through this query before we run it as well. So again, we're selecting something. We're making a timestamp value, as we saw in the first data set. And here, actually, we're doing what we did in the first data set, where we had these outlying values, these wind speeds of 999, these precipitation values of 100%, temperature of 1,000 degrees, or 10,000 degrees, sorry. I don't know if that's Celsius or Fahrenheit, but either way, don't want to be there. So we want to take these values, and we want to make sure that these values aren't included in our data set, because they would be really weird outliers, since these values aren't real. So we're just solving that right here with this query code, where this from command just selects, again, the data set that we were using earlier to make sure we're getting our data for the right thing. And we want to make sure we're using this where command, so we're drawing only the data that we need. So in this case, we're using data from 2008. And again, we're only working in LaGuardia and JFK airports, and we're grouping it by its timestamp. Remember, if you guys have some free time, mess around with these. Change these values around, group them by different things, sort them by different things. Have it, just play around with it. Best way to learn. So if we run that code, you can see here we have the temperature. So the temperature on July 3rd was about 77 degrees. So that's pretty cool. We can go through and we can see that in a whole bunch of different areas. All right. So I misclicked there. So one of the things we're actually going to do here, and this is very important, is we're going to be editing our query a little bit so we can actually save our results and process some analysis on them later. So to do that, we're going to click on this little gear here, and we're going to click on query settings. All right, so what we're going to do is we're going to set a destination table for our query results. We want to make sure our project name is our project and our dataset name is our dataset. So remember, we're saving it to our demos dataset in our Quick Labs project. It'll say Quick Labs-GCP and then some letters and numbers. It'll be different for everybody. So our table name here, we'll be calling it NYC_weather. It's very important that we type these right so that the Quick Labs make sure that it sees it. We want to make sure we also allow large results. There's no size limit. This is very important because we're going to be processing a lot of data. So again, for that table name, it's NYC_weather. And the result size is when we allow large results with no size limit. I'm going to leave this on screen for a couple minutes, see if there's any, or a couple seconds, see if there's any questions. That way we can make sure that we are ready to go. And just to reiterate, right, we're looking at dataset name is demos. That's the dataset we made earlier. Table name, NYC weather, _weather, and we allow our large results. So we're going to hit save. And we want to run this query again, just to double check. We'll just actually do the save. So here we can actually see we've added this table and we can preview it to see what's happening. And this is our query from earlier. All right, awesome. So if we go down, we want to check our progress, of course. Perfect. And we're actually going to go and we're going to change back to save query results in a temporary table right here. And this is important so we don't keep saving things to that table and we can run our future queries. So next thing we're going to do is we're going to find that correlation that we're talking about earlier. To do this, we're going to use the core function. Now, these are some docs. You can click on, read through these. These are very technical. But in general, what it does is it returns the coefficient of correlation of a set. So if you've taken a statistics course, you might be familiar with those terms. You might be dreading those words. But don't worry, there's no math here. We just need to copy and paste our code, maybe understand it a little bit, and be good to go. So again, it's a couple select commands. We're selecting here our complaints, our temperatures. We're selecting them from kind of our average is here. And we're going to keep going down. Again, it's just selects and froms. We understood those from earlier. Here we have a new command, a join. What join does is join takes two data sets or two tables and can kind of allow you to use both of them. So again, we have our more selects where we're selecting our date, our day count, etc. We're selecting them from certain things. So we're selecting them from our dates, descriptors. There's a lot of SQL here. So we're not going to go through all of it because we do have to make sure that our lab is submitted in 17 minutes. But just make sure that if you read through this, you understand these keywords: join, select, and from. we're grouping them by our date and descriptor. And the on command here is just where you join it on. So this is a little bit confusing sometimes, and I can probably spend an hour on this, but I'm gonna just spend like 5 seconds real quick. When you join something, you have to set the table, a row in the table to the other row. What I mean by that is if you look at two data sets, it has to know where you're joining it. So if you're looking, for example, at a data set that has, let's say, my name and my grades, and another data set that has my name and my personal information, the thing in common is my name. And so that's where you're joining the data set on, is my name. So this is what we're doing here. We're just joining it on the date to make sure that the data that's in common stays in common. Again, we're grouping it. This have command is very similar to that where command that we saw earlier. So you can essentially think of it the same way. And at the end, it just orders it and groups it. So let's go ahead and run that. Take a second here. Actually, it's a process quite a bit. 7 seconds for about a gig. A little slower than what we were running earlier, but we do get the results that we're looking for, and that's awesome. So let me go ahead. Perfect. So now we're just going to go and we have those values. Going to compose a new query. And we're going to take our next piece of code here. Wait. We just ran this. We did just run this. Make sure that we're running the right thing. Yeah, so now what we're going to do is I want to spend some time analyzing this data. We can actually go ahead and submit and end this lab. But there's a couple things I do want to talk about as we end this lab out to kind of make sure that we're understanding what's going on before I bring Andrew on to the next lab. So one of the things you'll notice is some of these correlations are negative. Just as a quick processing measure, why do you think that is? So let's take, for example, we have our noise. It's a negative correlation. Any predictions on maybe why noise complaints are negatively correlated with weather? Go ahead and post those in, again, those chats so that we can have a discussion. I see there's a problem with the query running too long. Sometimes that happens. If it's running more than like maybe 10, 15 seconds, I think you can try refreshing the page or doing something like that as well. Give it another couple seconds for a response. Go ahead and close these extra tabs. So we'll see that there's actually some coefficients here that are negative. And a lot of that, I think, has to do with maybe people are just quieter on windy days. Maybe it's harder to hear them. You know, the wind might drown out something. That's my prediction. The other question they ask is, you know, is it statistically significant? I'd argue that percentages, 0.6 is statistically significant, but you can definitely do the math to figure that out. We'll see here, for example, that hot water is definitely, with 0.6 correlation. You'll see that, as it gets colder or warmer, or the weather gets worse, we definitely see that people are reporting that more often. Another good example of maybe a maintenance kind of negative correlation here is we see some outside external structures that are kind of negatively correlated because people aren't going outside when it's cold. So that is lab 3. And so what we're going to do next is we're going to bring Andrew on. And Andrew's going to be going over, well, I'll let him talk about it, but he's going to be bringing in the analytics part and adding the ML in. So I'd love to welcome on Andrew to continue this lab, or can start with lab 4.
Hi, Aditi. Thank you so much for running through Lab 3. I wanted to highlight a couple of different things for people on why Lab 3 is so important. So don't get me wrong, it was awesome seeing how you could go through and track across 2 different data sets how weather data related to complaints. Don't get me wrong, that insight in itself is awesome. But I wanted to put one more highlight onto what we were doing. If you want to scroll up really quickly as well.
Yeah, sure.
And show the query where we made a new table.
This one?
One more up, I think.
Yeah, it was.
Here we go.
That was the one. Yep.
This is one of those things where you learn something new every time you go through it. But I thought that the point you made about the fact that what we were doing is really cleaning the data set. So we got, just the information we needed. And more importantly, as you mentioned, we filtered out some of the data that was obviously entered into the data set one way, but we didn't want to live anywhere where it was 10,000 degrees. That is a key part of anything you're doing with any data. And that's especially important as we start trying to go add machine learning to this, because if you get, garbage in, no matter how good your machine learning model is, it's going to tell you that, heat complaints go way up when you have, 10,000 degree weather. So, I thought that was something that they kind of glossed over a little bit in the lab in terms of why they did it, but that's a key data engineering thing. And if you're really interested, for anyone on the stream, of basically learning why we did that, there's a whole other tool you can use for data engineering called Cloud Data Prep, also part of Google Cloud Platform. It integrates really well with, BigQuery and all the rest of the Google ecosystem in terms of their data analytics stuff. But I wanted to bring that up for everyone that, these queries might seem like they're coming from thin air in terms of what they're doing. But if you're actually going through the whole process, there's a wide range of tools you can use to go gain these insights on your own. So thank you once again, Aditi. Great job walking through Lab 3. And again, that was some really cool insights with the weather data. So with that in mind, we're going to go, kind of pivot to a different direction here. So we spent some time looking at weather, and now we're going to head back to the land of e-commerce, where Bobby kind of walked us through some stuff with it yesterday. So what are we going to do? We're going to attempt to predict whether a visitor will purchase something based on where they're looking on a site, based off of a whole collection of BigQuery data. So again, I'm sure that all of you know this by now, but I just wanted to highlight it again in case anyone's joining the stream late or things like that. But BigQuery is a really awesome tool. What it does is it basically keeps up, all of the different infrastructure and provisioning your resources and everything like that for you, so that you don't need to do it and you can just deal with the data analytics. And better yet, it operates on a really big scale with terabytes and even petabytes of data really quickly. One of the things that Aditi mentioned was that, we crunched through almost 1 gigabytes of data in 7 seconds, and that was slow for BigQuery. But if you're, the system admin and you're doing all of, the hardware and everything yourself, a 7-second query on 1 gigabyte of data isn't actually that bad. So just in terms of, physically the power of the tools that we're working with here, it's always interesting to put it into perspective that, when BigQuery is running slowly, it's still outperforming a lot of traditional databases. And you don't even have to do anything with that. The other thing that I wanted to highlight for everyone is, again, we were using standard SQL. Aditi physically brought up the SQL docs from Oracle that said, this is how the SQL function works. So anything that you learn for, another database class or working with a traditional database, you can just pick all that up, bring it over to BigQuery, and start working with larger data sets. Now, that said, BigQuery has some extra features. If you really go into it, it can do things like arrays, it can do things like dictionaries that you don't see in a lot of traditional databases. So it's really powerful, and there is obviously more to it than traditional SQL, like machine learning, like we'll be adding here. But in terms of that learning curve, BigQuery allows you to kind of focus on analyzing the data as opposed to handling all of the admin. So let's go through here and kind of talk about, what exactly are we doing? Well, we're going to take a look at the e-commerce data set, which is Google Analytics data, which again, if you have your own, e-commerce site that you have, you can hook up Google Analytics and you can go get all of this data from your own site. But we're going to pull it from the Google Merchandise Store and load it into BigQuery. And in this lab, we'll use all this data, run some typical BigQuery queries to figure out different things about customers' purchasing habits. So this is a much longer lab than some of the things that we've done before. So let's kind of outline what it'll look like. So in this lab, number 1, we're going to use BigQuery and find public data sets, just like we did last time. Number 2, we're going to spend some time manually querying and exploring the BigQuery e-commerce data set. So what does this mean? Well, this means that we're going to kind of understand the data that we're working with. We can't just jump in and start, yay, we're going to apply machine learning to it. A big part of machine learning, as I kind of mentioned earlier, is being able to go do, that feature analysis and figuring out, exactly what parts are important and what type of insights we're looking for. So to start with that, we're going to do some machine learning using our own brains. Then we'll create a training and evaluation data set that we can use for batch predictions. Now, this is key because just like we created a table in the last lab with Aditi that had just the data we were looking for predicting the complaints and comparing that, we're going to do the same thing here where we take all of the data that exists, we're going to clean it up, we're going to take the subset we want and give it to its own data set. And once we do that, we're going to build a machine learning model in BigQuery Machine Learning off of that data set. We'll evaluate the performance, make sure that the model's working, make sure that our predictions of which features to add are good, and then we're actually going to predict and rank the probability that a customer is going to make a purchase. How cool is that? So, with all that being said, let's get started. So, first thing we do, we set up the environment. For those of you who have been around since some of our prep events, yesterday, going through this with Aditi today, I'm sure that none of this is new to you all, but just in case anyone does need a refresher, we're going to walk through everything step by step. So the first thing you're going to do, number 1, start lab. Number 2, verify that you're not a robot and select all of the pictures with mountains or hills. From there, what we're going to do is we're going to click on this Open Google Cloud Console button. Click. And we're going to go copy the username from QuickLabs. Now, really quickly, this is key. This is a different username than the one we had last lab. So make sure that you copy this, and you'll see, in fact, that my one from last lab is signed out. So we're going to click Use Another Account. We're going to paste that in there. And we can grab the password from QuickLabs. And for those of you who are familiar with QuickLabs, you go through this really quickly after a while, so we accept the terms. We confirm without adding any information. Again, the account's only going to last an hour, so you don't want to hook your phone number to it. Then we go through and we accept the terms. The final step here that I really want to highlight for everyone is double check your project. And we're going to do this at every time we open up a new tab. As Aditi kind of mentioned earlier when we were going through stuff before, sometimes things switch depending on which accounts you have. Using an incognito window is really key to avoid having any issues. But that said, especially because we're coming out of another lab, we've always got to double check. For example, what I like to do is verify that the project ID matches for those last couple characters. So in this case, it's ECC6, and this one ends in ECC6. So I'm on the right project. Now, with that, what we're going to do is we're going to open up the BigQuery console. So we did this last time through the navigation menu, and you can find it through the navigation menu. But in case you're new to Google Cloud Platform, I want to go show you this as well. Aside from finding it on this sidebar, we can also search for it up here. So if I just search BigQuery, boom, There it is. And I can pull it up directly. From there, yay, it's a new UI. I'll be the first to admit I haven't started using BigQuery when it was the old UI, but this one is really easy to use, and so I'm sure they've made a ton of improvements that have made it that way. And what we can do is we are open. So now, let us grab the data set. Now they go through and they provide a link. So what we're going to do is we're going to click said link. Google Cloud will do all of its magic to go basically import the public data set into our project. And now, just for fun, because we really like being careful, we're going to double check our project ID again. So again, it ends in ECC6 for me. My Quick Labs one is ECC6, so I know we're all good. Notice that because this opened up in a new tab, we can close our old BigQuery tab. We're not going to need it. We'll be using this tab. If we refresh the other one, they'll both have the same data as well. So we have gone through and we have set up the environment. Really quickly, if you're interested, we have all of the different field definitions in here that explain the different parts of the data. And this is standard for pretty much all Google Analytics. And as you can see, it's a big table with all kinds of information. Now, at the end of the day, this is only, a relatively short lab. And Quick Labs, one of the reasons why it's so cool is it already knows kind of which fields are important for us. So I'm going to defer to Quick Labs' judgment here. But, if you want to go through, and again, let's say you're using Google Analytics on your own site, maybe you're doing a small business type thing. Again, data definitions exist. You can do the same things we're doing here on the sample Quick Labs data set on your own data if you wanted to. So what's next? Well, we've gone through, we have everything set up, we've pulled in the data. Now we kind of need to get an understanding of, what does this data set contain? What are we looking at? Things like that. So we're going to go grab a scenario and figure out what the answer is. So your team or your data analysis team has exported the Google Analytics logs for an e-commerce website into BigQuery and created a new table of all the raw e-commerce visitor session data for you to explore. That's what we did earlier. Using this data set, we'll answer a few questions. So the first one, which is I'm sure on everyone's mind in terms of the data analysis, you have an e-commerce data set. Out of the total visitors who purchased, or who visited the website rather, who made a purchase? What's our conversion rate? So with that, we can copy and paste our existing query. We can paste it into the Quick Labs. And I want to really quickly just run through this query for the SQL a little bit. For those of you who are at the prep sessions, I'm sure this is just going to be review for you, but it's always good to understand what your query is doing. So first off, this is a construction you may not have seen before, but what we're doing is we're basically naming subtables here. So with visitors as, and everything past here, this SQL query, where we're selecting the count of distinct full visitor IDs as total visitors, what we're doing here is we're pulling out a table of the full visitor IDs, and that's all it's doing. Now we head down here, purchasers as. So we're going to select a distinct count of all of the total purchasers. Again, same data set. You'll notice that visitors and purchases is identical, except for one thing that's pretty important. In purchasers, we have where, which is basically a row filter, totals.transactions is not null. Basically, they made a transaction. Now, what's the result of this? Well, we take a final, query here to go put it together. So we have our total visitors, our total purchasers, and then the conversion rate, again, which is the total purchasers out of the total visitors. From visitors and purchasers as we define it up here, we can hit run. And so based on this data, you can see we had more than 700,000 visitors from this particular data set, and we had about 20,000 purchasers. So that means that about 2-3% of people that visited the site made a purchase. Now, I'm going to be the first to admit I am not a marketing expert. So I'm sure that if you actually talked to a marketing expert, they could tell you whether a 2 to 3% conversion rate is going to be good or not. But what I can tell you as a data expert is that I'm sure that if we focused our marketing effort more, we could do better. So from there, that's kind of what spawns this whole idea of, well, how do we predict if a visitor is going to make a purchase, and how can we maybe push those that will make a purchase kind of over the threshold so that they go from wanting to make a purchase to making a purchase off of our more focused effort to market based on our data analysis. So the other thing, always helpful to know, what products are you selling? You could go through and market, your doohickey as much as you want, but if nobody's purchasing the doohickey and every person is purchasing, the Flam Gym, you want to go through and make your ads for the Flam Gym. So we have another query here, and what we're going to do is we're going to paste it into BigQuery and again go through and figure out exactly what this query is doing. So we're selecting, you'll see that this is p.product_name. And we have p.product_category, and then we have our sum here. So we have product quantity as units sold, and then we round that to the product revenue as revenue. Now notice really quickly here that we have this unnest hits and this unnext h.products as p. Well, remember how I had mentioned that BigQuery is awesome and unique in the fact that we can do more advanced data structures in it? Well, what this unnest does is it actually goes through and it takes apart arrays and it takes apart different objects in each of these things to go figure out exactly what data we have. So really quickly, just to go take a quick look, if we head back to the web analytics section and we give it a preview, okay, maybe that one's not happy. Where are we pulling from? Okay, well, preview's not working for me at the moment. That's fine. But long story short, when you see that unnest, you're right. That's not standard SQL, but that's specific to BigQuery so that we can do better data structures. And then we're going to group by the product name and the product category. And once we do that, we're going to order by revenue because it's really important to go figure out which ones are selling the best. And we're going to just pick the first 5. Note that if we took the 5 out, it would show all of the products and their revenue, but we only really care about what's the top selling ones. So if we run this query, we can see from our analysis that the third generation Nest thermostat was the top selling product with more than 17,000 sold in this particular list, with a revenue of what, $800,000. It's not bad. Followed by Nest outdoor and indoor security cameras and Nest smoke detectors. And notice that even though some of these seem similar, we have wired and we've got battery. So this data that we have is not only for like the type of product, but sometimes even the exact SKU of product you have. And if you really dive down into this e-commerce data more, there's all kinds of other insights we can derive from this. But just at the basic level, this is pretty good. Now notice again how I mentioned, the whole thing about BigQuery scale. We just crunched through almost 1.2 gigabytes of data in less than a second. That is fast. So, another reason to go use BigQuery for something, as complex as this, we saw that this has more than 700,000 records in it from our last query because there are that many customers that come to visit. That's awesome that we can go process that data so quickly. So what else do we want to go know about this? We want to go figure out how many visitors bought on subsequent visits to the website. So what does this mean? This means that I went to the website, I went, wow, this is a cool Nest thermostat. Then I left the website. Then I came back to the website at a later time and actually made the purchase. So this is one of the key things we need to go think about as we're building up our machine learning model, because these are the types of visitors maybe we want to focus on more for our marketing efforts. So again, what we're doing here is we're basically building a temporary table called all visitor stats, which contains the full visitor ID, and we have the 740,000 number that we saw in our first query. And here's the thing. We're doing some transaction information here, processing, just like we did in the last weather one. So if they actually purchase something, so their transaction total is greater than zero, the transaction total, is greater than 0, and the totals.newVisit is null, then we print a 1, otherwise we print a 0. And so this indicates that they'll return to buy later. And then again, we have our standard stuff, grouping by full visitor ID, because the same full visitor ID can have different rows in the table based on, obviously, if they come back to the site more than once. And so again, this part is the key part of the insight here, because what we're doing is we're saying that they purchased, their total transaction is greater than 0, but the new visits is null, which means that they've come back to the site. And again, we can go through, is greater than 0. That way, we go through and we figure out if they'll purchase or not. And this is what we're going to base pretty much our entire machine learning model off of. After that, from there, just simple SQL. We're going to count, and we're going to count how many will buy, and we're going to group by the people that will buy on return visit. So basically, how many people yes, how many people no, because we've got a 1 or 0 here. We're going to run the query. And we found that there are about 730-ish people who won't buy on the return visit, and about 1,100 or 11,000 that will. Now, remember when we ran our first query? There are about 20,000 people who purchase on their first visit. So why is this information important to what we're looking at? Well, if we have 20,000 people who purchase, and we have 11,000 people, almost 12,000 people that purchase on a subsequent visit, well, that means that 8,000 people purchased as soon as they came onto the site. Which means we really don't need to keep marketing to them because they've already gone through and they've already purchased something. By the time we have any data on them, they've already made their purchase. So it's a bit too late to start marketing to them. So this is going to be the key insight that lets us build our machine learning model. So as analyzing the results, we can see that about 1.6% of the total visitors will return and purchase from the website. A little bit lower than our conversion rate of about 2.6, so about 1% just purchase, the first time they're there, the other 1.6 purchase, later. And this includes the subset of visitors who purchased on their first time on the site and then came back and purchased something again. So now we have another question that we need to answer, but this isn't data-based, this is contextual-based. Keep in mind that this is obviously a real e-commerce data set. So just looking at the numbers, you can nod along and say, yay, that's a lot of people. But what does that mean? What we need to think about here as data analysts is, what are our numbers showing us? Not just what are the numbers, but what does it mean? So what are some of the typical reasons an e-commerce customer may come to our site, they may look at it, but they might not buy until later? Well, obviously, this is when you have a big group discussion about different reasons. There can be more than one reason. Someone says someone's busy, someone finds the product, they might come back to it later. They're not sure if they need it or not. They're doing some comparison shopping. But I think that the comparison shopping is probably the biggest one. And you'll notice that a lot of these things that are high selling products, they were also pretty high end products. If you're buying a smart thermostat, or a smart smoke detector, or security cameras, you're going to want to do your research ahead of time to go make sure you're buying the right product, for what you're looking for. So in the world of online marketing, identifying and marketing to these future customers based on, what characteristics they have from their first visit will increase, hopefully, the conversion rate and reduce the amount of people that leave our site and go buy from one of our competitors. So, all that said, what are we doing? We're creating a machine learning model in BigQuery to predict whether or not a user is likely to purchase in the future. We're identifying these high-value customers to help our marketing team target them specifically with promotions and ad campaigns to hopefully boost our conversion rates, while they're comparison shopping between visits to our site. So, first up, we need to go figure out what our training data is. Now, if you really get into a lot of the machine learning stuff like this, you'll notice that there's a whole lot of the machine learning part that's focused on, which data do we use? Which attributes are important? How much data do we need? Everything like that. In this particular case, ultimately, we kind of have that laid out for us. But keep in mind that this part here is typically bigger in terms of the machine learning part than actually running the machine learning model, depending on exactly what you're doing. This is called feature engineering. And so we're actually going to spend some time on this as we go through and look at it. So as you can see, Google Analytics captures a wide range of data on the user's visit to the site, as we visit by like the infinite scrolling page of all the different things that it saved. We have the complete list of fields. We saw that one earlier. And we have a preview of the demo data set, which I'm going to see if this one loads for us really quickly. Load. Okay, it's not loading right now for me. Sometimes that happens. But basically what would happen is you've gone through, you've analyzed all the information, and we have determined two different things that we think matter in terms of coming back and figuring out exactly if a person is going to purchase again. Number one, totals get bounces. So a bounce is when the visitor comes to the site and as soon as they're here, boop, bye-bye, they're gone again. Obviously, that's a little bit disappointing. The other thing that we can do is the total time on the site. So, were they looking, were they browsing, or did they just stop in, go, darn, wrong site, and go through and, leave again? So, what do we know about this information? Well, ultimately, we're all human. And one of the big things for machine learning models is that they can find stuff that we might not necessarily see. For example, we might think a bounce is really bad because obviously they just left the site immediately. But at the same time, though, or we may think that a really low time on the site could also be bad. But what we may find out once we run this machine learning model is that there's different thresholds, and it's not quite as binary as we tend to think about it as humans. So that is why we're going through and building this machine learning model, because whatever preconceived notions of what we think the data will tell us, until we actually run a machine learning model on it, we won't know for sure. So the big question here is, though, why are we only using these two fields? Well, they're the ones that we see most identifiable, and sometimes when you're first getting started, adding too many fields will kind of confuse the machine learning model. At the same time, though, we're only using two fields. So what are some of the risks of that? The machine learning is only as good as the training data that's fed into it. If we don't have enough information to determine, the relationship between our input features or our input fields and your label, so that's basically what the output is, in this case, whether the visitor has bought in the future, then you won't have an accurate model. And so while training the fields on these two models is a really good starting point for us, we're going to find out as we play around with it that maybe it's not as accurate as we want. So what we're going to do here is we're going to basically build a data set. And we're going to copy and paste this into BigQuery. We're going to do new query. And we're going to go take a quick look at this. So what we're doing is we're grabbing everything except the full visitor ID. And we're going through and determining some of the features from this table where we have full visitor ID. We have the total bounces, or if it's null, 0 as bounces. Then we have the total time on site, or 0 if, again, it's null for the time on site. Typically, what would end up happening was if you bounce, so we have, a count of more than 0 for the bounce, then we have 0 for the time on site, and, obviously vice versa for that one. And we're pulling that out from the data analytics such that our new visits is equal to 1. And this is coming from and joining with the full visitor ID. And notice that because we're joining it here and we have full visitor ID here and full visitor ID here, we're going to, basically string the two of these together and we'll see that we have this line here before. Does this look similar? It should. We used this in one of our manual queries to predict whether someone will be purchasing or not. Well, why is that showing up here? Well, we need to give the machine learning model answers in order to go train it. So what this is doing here is we're giving it two features where it's either, they've bounced or they haven't, and how long they've spent on the site. And with those features, then we're also giving it whether or not they'll buy. And we're going to group by full visitor ID. We're going to order by the time on the site. And we're just going to limit it by 10 here, because this is just for us to go look at. We don't need the full data set. When we go build the query, obviously we're going to give it the full data set. But for right now, just for us looking at it manually, we don't need it. Now, again, notice how we're selecting everything except the full visitor ID. So what this does is it basically tells the machine learning model, here's a whole bunch of data. We're going to tell the machine learning model, this is the answer right here, that transactions number, and if they'll buy again. These are all the features. By excluding the full visitor ID, it will make sure the machine learning model knows that the full visitor ID doesn't change whether or not the person buys on the site. That's not a feature that we're looking to go train a machine learning model on. The rest of it is, though. And when we run this query, as we can see, we've picked, just 10 people who spent the most time on the site. And if we look at it, I'm going to hide the editor really quickly. Here we go. Notice that we only had one person buy on the site, which is really interesting for me because on the one hand, they haven't bounced. So obviously, they've made it to the site, they haven't bounced, that's going good for us. But despite these people spending so long on the site, they never actually purchased, which makes me think that maybe they just left the site up in the background or something like that. So what the machine learning model is going to hopefully do for us is figure out what this magic sweet spot is. Looking at, our random 10 data samples, it looks like it's going to be, 9275 that says, at this time, visitors will purchase. That's the goal. We'll see if we get here, though. So we've done that. We have our results. The question, which fields are the input features on the label? Really quickly, we went over this actually. Oh, it says below, so we're gonna hide that. Anyway, though, the bounces and the time on site are the input, our features, and the label is the will buy on return visit. That's what the answer is. So, which of these fields are known after the visitor's first session? And I want to actually throw this one to the comments because this is really important in terms of how you do machine learning. So I want to kind of throw this out to the comments, throw this out to YouTube chat, throw this out to Discord, but it's really important that you know the answer to this one. So again, which of these two fields are known after the visitor's first visit? And we'll just wait for people to go answer really quickly.
"12 seconds later."
Okay. What ones of these are known after they make the first purchase are the bounces and the time on site. The key thing here, which field isn't known until the future? Whether or not they'll buy. So this is really, really important for any sort of machine learning stuff. That the will buy on return visit isn't known until after they've already made their first visit and have come back. And since we're predicting a subset of users who have returned to the website and purchased. But since we don't know the future at the time of the prediction, you cannot say with certainty that a new visitor comes back and purchases later. So the value of building the machine learning model is to get the probability of a future person based on the data gleaned from this first session. Now, the other thing I want to highlight too, from a feature engineering perspective, is I can tell you our machine learning model will be pretty much 100% accurate if we go through and use will buy on return visit as one of our features, as one of our inputs. I can guarantee you that'll be highly accurate. Unfortunately, that also won't be, or unfortunately, it will also be highly useless because by the time that we have that data to put into the machine learning model, it's already too late. They already made the purchase, you know? So what we're looking to do here, and you've got to be really careful about this, and this goes back to some of the stuff about data and feature engineering, is you've got to figure out which fields you know at which points in the process, and make sure anything that you kind of derive from the data and, derive from a bigger picture than your machine learning model will have isn't used in your machine learning model. Your data set may be totally awesome with all the data in the world you can want. But if the machine learning model only has a small subset of that to work off of, you've got to restrict your inputs on machine learning model to that subset. So the other thing here, looking at the initial results, do you think that time on site and bounces will be a good indicator of whether they purchase or not? Well, it's too early to tell. But for the top time on site, there's only one person who purchased. So at the very least, it's not going to be binary. It's not going to be, if they spend, very little time on site, they won't buy. If they spend a ton of time on site, they will buy. And what we don't know is maybe there's a threshold. We only grab the top 10 as well. So maybe there's, a spot in the middle where that's true. And that's for the machine learning model to figure out ultimately. But, from the data engineer in me is saying, my initial predictions as a human aren't quite what I thought it would be. I thought that if they spent more time on site, they'd purchase it. And that's not looking like it's true. So if the machine learning model can go kind of suss out something that I don't see, good for it. But it's also starting to, kind of set the stage for me to go think about maybe we need more data. And we're going to come back to this once we go and evaluate the model. But right from the beginning, when we do our manual checks, even before training the model, we can kind of get some guesses on how things are going. So what's next? We've done our manual explanation or our exploration. We've gone through, we've selected which features we're going to be using in the training data set. Now we're going to create a BigQuery data set, just like we did in the weather lab, to go store the important data that we can just pull in to go train our models. So first thing we do, we need to create an e-commerce data set. And so I'm going to copy e-commerce now, because I know that my spelling is not very good, and Qwiklabs does not like it when you misspell stuff. But what we're going to do is we're going to head back to BigQuery. We're going to scroll up, and you'll see our project ID. Again, this is your perfect time to double check that you are on the right project ID. I happen to know that mine ends in ECC6. We have ECC6 here, so we're all good. From there, I can click on it, and I can create a data set. And again, we're going to name this data set e-commerce, because that's what Qwiklabs wants us to do. If I was working for a marketing firm, I might call this, company specific dash e-commerce. I might call this, e-commerce dash machine learning prep, or things like that, depending on, what other data sets I have. But for what we're doing now, e-commerce is fine. The other thing that's worth it noting is that we do have all kinds of other options. This is something that I thought was really interesting, but we can choose actually where the data is stored, which is awesome if you have, legal requirements of something like, for example, I know there's a lot of European laws that requires that certain data only be stored in Europe. Same thing with a lot of laws in like South Korea or in India. The US doesn't really have a lot of those laws. So depending on which data set stuff you're working with, it can end up anywhere in the world for some of that stuff. But it's cool to have that feature. It's cool to have table exploration. So maybe you're limited to only have this data around for 90 days. It can also help you with costs as well, but we're doing an hour lab, so we don't need to worry about that. And encryption, again, really cool. Google automatically manages encryption, which 90% of the times is what you need. But if you've got really specific requirements, it's cool you can change all these settings. That said, we're doing a quick lab. We literally have like 45 minutes left, so we don't really need to worry about any of those, and we can just keep the defaults. So as you can see, we have our e-commerce data set. Notice it is empty. Creating a data set is not the same as creating a table. So our next step is to go check that we have created a data set. And I'm going to go pause here for just a second to go kind of let everyone catch up. Make sure that you do get the green checkbox for creating the data set. If you don't get the green checkbox for creating the data set, that's totally fine. We have tons of great mentors in the Discord. Just a quick look at it now, it looks like all of them are available. So if you've got a question, now's a perfect time to go stop by. And we also have people moderating the YouTube chat, and we've got people moderating Discord text channels as well, so that you can go through and get any and all questions answered, because this is going to be key for going forward. Okay, so now we're going to select the type of model we want to train and specify some of our options. So now that we have our initial features selected, we're ready to create our model. Now there are two big types of machine learning models we can choose from when we're using BigQuery machine learning. Now, if you're using something, like TensorFlow, or you're using something like Google AutoML, obviously your types of model options will be different. But we're working with structured data, i.e. a table. And so because of that, we have a little bit different types of models than you're working with than you would see in like a quote unquote traditional machine learning problem. Going back to, our puppy muffin model or the bee model that we talked about earlier today, both of those operate on unstructured data. So we're going off of, images, we're going off of video, we're going off of, basically trying to go pick things out in pixels, which is really difficult. And we just kind of tell the machine learning model, go figure it out. In this particular one, though, on structured data, we can give it a little bit more of what we're doing, because analysts have been able to go do this sort of thing for years. Machine learning model takes it to the next level, but we as humans at least know how to do this. So there's two types of things that we're looking to do on a table. Number one, forecasting, linear regression. The data label type, i.e., and remember the label is the output ultimately, is a numeric value, typically an integer or a floating point. And this is used when you want to go forecast, sales data over the next year given historical data or costs or things like that. This forecasting here is what you'll see if you ever watch the news and they've got the magical stock market charts and they're like, this will go here, or in your corporate boardroom meeting, these are the types of charts that you use when you look at the end of quarter financials and say, we had a great quarter and magic, all of our numbers will go up next quarter. That's that sort of model. Notice though that the numeric data type is typically an integer or a floating point. Well, technically a 1 or 0 is an integer, but it's designed to go basically project. What we want to do is we want to go classify. So this is a logistic regression, which we use basically a binary 1 or 0 for classification. And this is great because for an example like classifying whether an email is spam or not, or whether someone will purchase or not. Note there are different types of machine learning models again that are available out there for different things, but we can do it. The other thing that's worth noting is that sometimes we can have classification with more than just binary. I don't remember entirely if BigQuery supports that yet. I know that was on the planned feature list last time I saw some more in-depth training on this. I don't remember if that's included or not, but keep in mind that when you're doing logistic regression, maybe we have a third category, buy first time, buy later, or don't buy at all. And we can kind of adapt machine learning models to that depending on which data we have. But in this particular case, because again, we're looking at the binary data, will buy or won't buy, we're going to use a logistic regression. So the following query creates the model and specifies all of our magic options. And we're going to copy this. I'm going to go through and train it because it's going to take me 5 to 10 minutes to train. And while it's training, then we're going to go through and explain exactly what it's doing. Now, again, highly recommend for everyone here, go through, copy, paste it in, because we're going to be waiting just a touch for this model to go through and train. The fact that it runs in 5 to 10 minutes and we're building a machine learning model in that short period of time is amazing in and of itself. But we still need to go give the time for the computer to go work, for the computer to go try it. So while it's training, let's kind of talk about what exactly we're doing with this query. So the first thing is we're creating or replacing a model, ecommerce.classification_model. Now, first thing to highlight, SQL, create or replace. What this is doing here is it means that we can run this query again and again and again with the same name without SQL going blah, and basically telling us, you already have a table there, don't overwrite your data. So how this one works here is it will go through and it will save a new table, or it will overwrite. Or in this case, because we're not limited to just SQL and we get to use all the full features of BigQuery, we're creating a model. Now, what do we call it? E-commerce.classification model. Notice that this e-commerce is our data set, and the classification model is the name of the model. This is why it's so important we named it e-commerce earlier. If you wanted to go call your data set, e-commerce dash, machine learning model or something like that, you could do that. But you need to make sure that your data set that you gave the name here matches the data set name you have here. Otherwise, BigQuery isn't happy. Now, we're creating a model. We need to give it some options. So what are our options? Number one, model type, logistic regression. Basically, which type of model are we building? That is all set there. Number two, label. This is what our feature is, i.e., what do we want the model to go tell us? Will they buy? And then all of this here, all of this code should look very familiar because it's the same manual code we ran earlier. We're grabbing the features. We're grabbing, in this particular case, a date range. So we want to train on the first 9 months of data. And this is really important. And I'm going to tell you why later. And we're going to join all of the data that we saw before. Here's the features. Here's the rest of the group by. Literally everything except for this where statement is exactly what we ran when we were doing our manual analysis of the data. So with that said, we have trained our classification model, and we're going to go through and do some work with it. Again, I do want to come back to why we only train on the first 9 months of data later, but because we have the model, and I happen to know we're going to be training another model later, we'll come back to that particular topic. So again, once it's trained, you can check your progress, and obviously we're good. Again, the key statement here is that if we look here, there is a classification model in our resource tree, which is awesome. So after that, we can go to the model. We've clicked on it. Now we're going to evaluate the performance of the model. So what we're basically doing is figuring out, is this model any good? So we have different performance criteria. So for a classification problem in machine learning, we want to minimize the false positive rate, which is when basically the model goes through and says, yes, they will purchase. And in reality, they don't purchase. Predictive user will return and purchase, and they don't. And maximize the true positive rate, i.e., our machine learning model is right. So the relationship is visualized with an ROC, receiver operating characteristics curve, like the one shown here, where you try and maximize the area under the curve. Now, if you're a math nerd like me, you can do all kinds of different math stuff in terms of integrals and everything to calculate what the area is. Realistically, though, if you're just looking at the curve, you want it going as high as you can and staying as high for as long as possible. So as you can see, when we have this sort of curve, obviously it's significantly better. Obviously for the yellow curve, it's not bad when it's the pink curve there. And when you go through it, you get down to the blue curve. That's when literally it is a 50-50 coin flip. Yay! The model is as good as it is statistically. If you were just to say, flip a coin, they'll come back. Flip a coin, they won't come back. Flip a coin, they'll come back. So at that point, that's when you want to go through and redo your model. Note that if you ever see a model that is like the opposite end of this curve, so it starts low and it goes high, then something is really wrong because your model is doing worse than it would statistically. I don't think you'll ever see that. But obviously worth looking at what your curves are to go figure that out. So in BQML, we can go through and we can actually query this information when evaluating the trained model. So we're going to run a query that literally goes and calls evaluate. And we're going to copy this. We're going to paste it in there. And as you can see, we grab physically, because the model acts very similar to a table does in traditional SQL. We're going to grab the ROC, ACU, and the case. We're going to basically go through and add a descriptor of it. Good, fair, decent, not great. Otherwise, it's just flat out poor if it's doing worse than it would, if we were statistically doing it from the prediction model. And we're going through and giving it some data to go basically test this model on. Now, why are we giving it data? You notice, hey, look, this query looks familiar again. It's almost like it's the same query we did when we were doing things manually, and the same query we did when we were training the model. But this time, we're evaluating on 2 months of data. Now, why do we do this? This is key for machine learning. You can't train your model on all of the data that you have, because otherwise, when you come back to evaluation, it will just go through and recognize the same data you gave it when you were training it and know exactly how to handle it. If you really want an unbiased evaluation of your model and you want to go test it to go figure out when it's good enough, then you've got to go through and give it separate data for testing, training, and evaluation. And the numbers that I've heard typically when doing this is you want, like 60 to 80% of your data to be training, 10 to 20% to be evaluation, and 10 to 20% being your testing data. So if we actually run it, what this does is, again, we're giving the data new model we're giving the model new data it has never seen before. And in doing so, we get that it has a ROC ACU of about 0.7-ish. It's decent. It's not great. We could probably do better. The other thing I did want to go point out really quickly, we've ran this as a query. If you went over to the classification model and evaluation, it gives you all kinds of information as happy little charts for it. I'm going to hide the editor really quickly. So we went through and we actually queried it on different data. But when it did its training, it had some data that it automatically kind of reserved out to go test all this out. And you'll notice, I believe, we can't control these metrics. Depending on exactly which machine learning model you can do, you can actually go and drag around certain threshold parameters to kind of tune the model yourself once you're done. Oh, wait, here we go. This is the threshold that we can go take a look at. And as we move that bar, it kind of moves us along the chart of some of our different data for this. But basically, what the end result is here, and we're gonna pretend that we didn't mess with that. Generally, you don't unless you know what you're doing, and obviously, I don't. There we go. It's back to where it was. But for this one, we have all of these as graphs. We have all of these as written data, and we can query it, but we can also view it in the UI. In the meantime, though, we've run our evaluation, and we can go check our progress. And again, our goal is to get as close to 1 as possible as we can. And if we hit 1, it means that our machine learning model works every single time. Obviously, we're not going to hit 1, but we could try and do better. So what do? We're going to improve our model performance with feature engineering. As we hinted earlier, there's many, many different features in this data set that could help us improve the relationship between, if they visit on the first session and the likelihood they'll purchase later. So we're going to add some new features and create a second model called the classification model 2. We're not very inventive today. We just want to call it 2. So we've got our original one, we've got our new one, and we can go through and we can go then compare the two. So what features are we adding? How far they got on the checkout process on their first visit? Where the visitor came from? Did they come from an organic search like Google, the search engine? Did they come referred from another site? Which device are they on? Are they on a mobile device, a tablet, a desktop? Maybe geographic information changes a role of what you're purchasing. So the country information. And so we're going to create a second model with the query below. And again, I'm going to go paste this in to our query editor. We're going to run it, let it start training, and then we'll kind of take a look at what this means. So again, notice this looks really similar to everything we've seen before. Create a replace model. We're going to call it classification 2. It's logistic regression. The label is still will buy on return visit. Our features are still the same. Or sorry, our labels are still the same. And note here we have all visitor stats. This is familiar. This is the same way we got our labels before. That hasn't changed. What we're doing new here is we're grabbing more different information. So we have sessions IDs. We've got behaviors on the site. So now notice we're looking at the number of pages they viewed. What else do we have? we're grabbing the traffic source, the traffic medium, channel grouping. Again, if you really want to know what all of this is, somewhere in the quick labs. Oh, here we go. Field definitions. Again, we've been to this link before, but this goes and it tells you, traffic source dot, what's a good one here? Traffic source dot source. Traffic source dot medium. So the medium of the traffic source could be organic, CCP, which I believe is basically a click, a referral for this. And if we actually grab the source, it could be the name of a search engine, the referring host name, or the value of basically a URL that they got referred from. So you can go through and see from the schema physically which information we're pulling into the model. Device category, geographic information as the country, and then the rest of this all is pretty similar to what we had before. We're going to train on 9 months again, and this time we're just going to make sure that we group by all of them that happen to have all of the same information. Now you'll notice that this model looks like it's running a bit longer. Well, why is that? Well, it's physically doing more work. Our first model was much smaller and much easier to do because it physically had less data to think about. As you add in more data, we exponentially increase the complexity of our model in many ways, because physically it's got more combinations of ways it can rearrange the data and play with it. And what do these numbers do? And if we group these numbers on these priorities and these numbers on lower priorities, what does the data come up with? Things like that. So again, another reason to go do feature engineering is because if you have fewer features, your model will train faster, which is why it was so cool we were able to get the first model so quickly. At the same time, though, it's BigQuery. It's fast, it's powerful, and we still got a new model in under 3 minutes, for a machine learning model. That is awesome. So just like we did before, we have our new model. We're going to check our progress. We're all good there. Now we're going to evaluate the model. Notice that all of this evaluation information, I'm just going to copy it, put it into BigQuery. All of this evaluation information is exactly the same as what we did before. We have the ROC, we have our description of how good the model is. We're evaluating it, just this time it's from model 2. And all of the rest of this information down below looks familiar because it's exactly the same query we did when we were training it. So we're going to run the model evaluation. It's going to go through, dump a whole bunch of data through the model, and we're going to get that our ROC ACU is 0.9. That is a good model. If we could get it up to, 0.95, that's probably realistically the highest you're ever going to get for a machine learning model like this. So 0.9 is awesome. And I did want to highlight this really quickly from the UI. Notice we can just see visually how good it is. Look at these curves here. That ROC curve, it's not bad, but it looks very similar to the pink curve we saw when we were looking at that chart earlier. If we get down to classification model 2, much, much better curve there. We've got much more area under the curve. It's much more up than over. And so you can see, just visually looking at the graph, this is a better model. By adding these new features, we physically did a better job in terms of evaluating all of this information. So we have evaluated it. We checked our progress, get quick labs to say we evaluated it. We're good. Now this is basically our final stage here. We have our model. It's trained. We've evaluated it. It's a good model now. Now let's go through, give it some data it's never seen before, and we're going to go through and we're going to copy it. Again, our query. We're going to paste it into our query editor here. We're going to run it. And again, now it's the same thing we did before, just this time we're calling to predict instead of to evaluate. All the same information data for how we fed it. The data is, the same. And now we get back. I'm going to hide the editor again. This is the prediction on whether or not it will work. And remember how I said that BigQuery was cool because it could have things like arrays? Well, this is an example of an array right here. We have row 1. Will they predict on purchase? And then we go through, and the label physically is 1 they'll predict or they'll buy, and 2 is, and 0 is they won't buy. And we have the probability of each one. So again, this is when more important when obviously you have a, let's say a more complex labeling system. Maybe you've got 3 or 4 categories. That's when these probabilities are important. But you'll notice here that this first customer has about a 50% chance of buying. not bad. Maybe we'll send them an ad or two, but we're not going to, spend a whole lot of money advertising to them. This person has an 80% chance of coming back and buying. We're going to be sending them a lot of ads, and just as you're looking through this data here, we can go pick out, and you can do all kinds of queries. And remember here, this is a table in BigQuery. Remember how when the weather data, we took a query and we turned it into a table? If we wanted to, we could save all of this query information to a table that we can run regular SQL on to go analyze it and figure out exactly how that works. So we've gone through, we've made our prediction on the last month of our data set that the model has never seen before, and we've got actual information on whether they'll be purchasing or not, and we can check. Remember, everyone, there are still lots of people willing to go help in the Discord for the Q&A lobbies, in the YouTube chat, things like that. So even as I'm wrapping things up, people are still willing to go help. But just kind of as a wrap up, we've done pretty much everything that we're doing at the moment. We output, as you can see, the 3 new fields. So it's predicted, which is whether or not the model thinks it'll buy. Obviously, one thinks it'll be yes, so at least 50% chance that they'll buy, as long as the probability that they're going to make that purchase. So notice, again, as we talked about, all of these people in the model predicts will buy. It's more likely they'll buy than they won't buy. But there's variations on how much they're willing to buy. So we can go through, and if I was in marketing, I could go through and say, okay, well, we'll take this and we'll start marketing to the people that have like an 80% chance of buying. And then we'll see how much budget we have left. Then we can start marketing to people who have a 50% chance. They're all predicted to buy by the model, but even in this case, the final label may not be what we're looking for. It might be more of these probabilities, and we can go work with that. So the results of the top 6% of the first-time visitors, more than 6% will make a purchase later. These users represent nearly 50% of all the first-time visitors who make purchases later. Overall, only 0.07% of first-time visitors will come back to make a purchase later. And so by targeting the top 6% of these first-time people, will increase return on investment by 9 times versus targeting them all. Again, just think about this really quickly. If you have the same marketing money and you go through and you spend it, 1 ad to everyone versus, 9 ads to the people we really think are going to buy, that is a 9 times return on investment. That's awesome. So we've got some additional information here. If you're retraining an existing model, we can do a warm start to go build upon it. And that, again, we saw all the different graphs that were available there. There's different ways you can actually measure a model. The ROC is not the only way you can do it, as we demonstrated by the graphs. And as you get more advanced in machine learning courses, that'll be, there for you to do. Finally, there's other data for you to explore. For example, taxi trips is another really cool one that I know there's a quick labs on about figuring out what the average taxi fare is using machine learning BigQuery models. So finally, we've got one last question, then we're almost done with the lab. So this one's way back from the beginning. With BigQuery, you can query terabytes and terabytes of data without having an infrastructure or without having any infrastructure to manage or needing a database administrator. Again, that one is true. BigQuery lets us do all of this. And notice we didn't need to stand up any servers. We didn't need to go through and figure out, how are we structuring tables. It just happened and it worked. And it was good for us to go find the actual insights. So that concludes predicting visitor purchases with a classification model in BigQuery machine learning. I know that this is long. I know that this is a ton of information, but I'm hoping that you guys learned a lot. And I'd like to go bring Bobby and Aditya back on the screen so that we can kind of wrap everything back up for you. Oh, and really quickly,
Wow.
Make sure you end your lab.
Wow. Awesome job, Andrew and Aditya. Let's get a big virtual round of applause in the chats going for them both. Some great work. Hey, I loved how you used this information to train your own models. It's almost like we could predict the future. Although that might not be a possibility, this is as close as it gets. And I think it's safe to say that we don't even need machine learning to predict the future of everybody viewing this. It's 2:00 Central Time right now on a Sunday, and you're all still watching. And I think that's just a testament to the skills that you've developed and how far you're putting yourself ahead of everybody else. today. So great job.
Yeah, definitely. And I mean, thanks, Andrew, so much. Some of those explanations were absolutely brilliant. I mean, y'all just made a machine learning model and understood what you were doing in less than an hour. That just speaks to the power, really, of what we're doing here. But also, you guys get to understand some of those amazing insights that Andrew really got to bring. So I hope y'all really learned a lot.
Yeah. All right, let's go ahead and share the slides here. We've got Keep Playing to Win. So just a heads up to everybody, we will be coming back. So via email, you will receive a link to the challenge lab. That'll be the final lab for this Cloud Hero. It's something that to be done by yourself, so you won't receive as much help from us. That's what really determines the rank and the scores. Keynote, only the 50 top scores will be displayed in the leaderboard, including your own. So if you're below the 50, you'll still see your own score. Otherwise, the top 50 will be displayed. But make sure to complete the labs, including the challenge lab that you'll receive via email by December 6th at 11:59 p.m. Eastern Standard Time. Let's go to the next slide. All right, and another plug for Developer Students Club. So you all know that this event was hosted by your regional developer student clubs. So be sure to go to the DSC website, dsc.community.dev. Click on the chapter heading and find your local DSC chapter. If your university doesn't have one, be sure to join any other universities to see what other events they have coming up to teach you the skills that you need to further your potential in the area of tech.
Really quickly, to build off of that, make sure that if you haven't already clicked the Join Virtual Event link for this event today, you make sure and still do that. That'll make sure that you're checked in for this event, which is great in terms of making sure that your attendance is recorded, and so that the people who are marketing, all these different DSC events to you know that you're someone who's likely to come back to events, and that, they should spend their marketing efforts, trying to get you to come to things.
And don't forget to like and subscribe to this channel. We've got a lot of great content coming for you all. So be sure to tell us what you like, what you don't like, what you want to see next. Where do you want to apply this machine learning in your own life, in your own projects, for your own solution challenges, and what sort of technologies do you want to learn next? Put them up in the chat. We want to get feedback from you because that's what we're here to do. We're here to cater to you guys.
Absolutely, y'all. Please in the Discord also after the event. And you'll also probably be getting an email registered through the community platform asking for some feedback. So go ahead and let us know. And I believe we have a demo also of how the community platform works. And I think we'd love to chat.
Yeah, so let's go ahead and bring Sahil up on the screen if he's ready.
Hey.
Hey, Sahil.
Hello.
Hey, how's it going?
What's going on? That was awesome. All of y'all. I learned so much from listening to all of you. That's incredible. So we're opening up the platform page.
Yeah,
Yep.
Can you show us how to join a chapter and how to find the events?
Yeah. So let me share my screen in just a second. Okay. My screen's up.
There we go. We
You're
got
online.
it.
All right, awesome. So after you found your DSC chapter, which was shown in the GIF before, you go ahead and click join, and that will make you a member of the chapter. As you can see, I'm on the Stony Brook University DSC chapter, and on this page, I can see all the upcoming events and the previous events. So I'm going to go ahead and check out this Flutter event that's coming up, where we're building a chat app using Flutter. To see the details, I'll click View Details, and if I'm interested, I'll just press RSVP. So click RSVP, fill out my name, my email, preferred pronouns, what I'd like to do, and just fill out this and press submit. And that's it. I'm registered to join. And once the event is live, just click join virtual event here, and it'll take you right to the live stream.
Awesome. Thank you so much for that demo. You know, it's super easy to join a club. Make sure you click that join button, because that's how you'll get emails from your club for future events and for notifications that your club has. So make sure to click the join button, get those emails, join the events, continue following us, like and subscribe on the YouTube video to make sure that you're up to date with everything that we're hosting in the future. And we're really hoping to see a lot of friendly names, a lot of friendly faces back at our future events. So once again, thanks everybody for presenting. And we can get my screen back up there. There we go. Hey, closing it out. Thanks again, everybody. If you have any other questions, feel free to put them in the Discord channel. Put them in the YouTube chat, and we'll be happy to answer them.